Welcome to Spring LIB.
So we're going to have two springs here attached to some mass m. So we'll call this K1, and the second one can be considered K2. And we're going to talk about the forces acting on this mass. Now, when the mass is stretched some distance x, right, it's going to have an acceleration of d squared x dt squared, right, and a force of that times m. But the red spring here, right, is going to be providing the restoring force, right, of minus k2 x2. And the key thing here is that x2 is not equal to x, because at the other end of this spring, it's going to be pushing against it. So although it's going to be stretched on the right by some distance x, the left end is going to move as well. And so they're not going to be equal to each other. But we do know a couple things. We will know that the combined stretches of those two springs is given by this, and the forces of the two springs must be the same, right? So they're going to push with each other the same here. And so I'm going to solve this for x1. So I get k2 x2 over k1. And I'm going to take this and plug it back in, right? So we have k2 x2 over k1 plus x2 equals x. And I'm going to factor out the x2 here. And I'm going to solve for x2. Make that a little neater. That's x over 1 plus k2 over k1. And then we're going to get to plug that in over here, right? So this is minus k2, and then x over 1 plus k2 over k1. I don't like fractions and fractions, right? So I will handle that. Okay, and this is the key thing, because this quantity right here is sort of like your effective spring constant for these two springs together. And so if I want to know the period, it's just supposed to be 2 pi times the square root of m over k. I just plug in that k, right? And so that's going to give you the appropriate thing. Now, we have a different problem where we want to have two springs that are kind of working together. This one actually ends up being an easier problem, right? So we're going to have, here's K1 with the mass in between them, and here's K2 on the other side. But in this case, whenever this guy moves a distance x, right, K1 is going to move a distance x, and K2 is going to move a distance x. And so there's actually two forces on this, and they're both working in the same direction, right? Both going opposite the motion. It's minus k1x and minus k2x, right? So if you look at the force from this side, if I compress that spring, the spring is going to push back out. And if I go to the right-hand side, if I stretch that spring, then the spring is going to pull back. So they're both going opposite direction. They both move the same distance x that the mass is moving. And so this one, you end up with this being your effective spring constant. And so if you go look in our formula, m over k, here we just get to add them. Whereas before we had the weird sort of reciprocal rules. There you go.